Manoj sir to introduce our resource person for the second session.
So, good morning to one and all. I feel very happy and privileged to introduce our second session speaker, Mr. Ankit V. Raghavan, who is currently working as a delivery lead, operation and delivery lead at Auto VRC. And he holds a BE Electronics and MSc Physics from BITS Bilani, Rajasthan. He has been working in the field of AR VR since 2017 and has helped scale Auto VRS from a 4-member startup to a 24-strong company today. So he has helped deliver over 40 plus projects across industry verticals, including conceptualization and planning the largest countrywide VR development across 20 plus showrooms for one of India's biggest home appliance retailers. Actually, hope this particular introduction will see about the efficiency of our today's speaker. I welcome you, sir, to this Friday FDP program. Thank you, one and all.
Hello, everyone. Can everyone hear me? Am I audible?
Yes, sir. Audible, sir.
Okay. Thank you, sir, for that nice introduction. Very flattering words. Thank you. So today's session, first of all, actually, let me first apologize if there is some slight disturbance in my background, some construction activity going on behind me. So there might be some slight disturbance, but if anyone is unable to hear, please let me know or just message on the chat and I will try and rectify it. Okay, so I think we can start the session. We're already a little late, I believe. So I'll try and move through the content as soon. But what I would like to say is, if anyone has any doubts at any point, feel free to unmute yourself and maybe ask any doubts if you have. Of course, at the end of the session, we can still have another Q&A or some queries or any doubts you have. We can always answer it. I'll be happy to answer it. But even during the session, if anyone has any doubts, feel free to just, either raise your hand or, just unmute yourself and ask a question. No problem. So I shall just go ahead and share my screen. Just give me 1 minute. Is everyone able to see my screen?
Yes, sir.
Okay, that's great. So,
sir, can you please can you switch on the camera, sir, if possible?
So I have a slight internet issue. Like my bandwidth isn't that great. Like this happens during video calls as well. Like it might start lagging if I'm streaming both video and sharing screen at the same time. It might start lagging a bit.
Okay.
So that is why I think it's better. The content is a little more important.
Right? Okay,
so
no problem.
I'll just share my screen. Maybe in the end, I can switch on the video. Once I stop sharing my screen, I can switch on the video.
Okay, sir. No problem.
Sure. Yeah. Thank you. Okay. So basically today's, this session is going to be a little bit about, VR and AR. What I will do is, I will run you through a brief introduction of AR VR. When I say introduction, I think in the last session that was supposed to be the intro to AR VR actually. So here what I'll do is I'll tell you a little bit about the history of AR VR, how we have arrived where we are today, why are we doing what we are doing today, why are we doing it, how have we arrived at this particular juncture, and what has brought us to the current state of the art and state of development of VR AR as we know it today, right? And of course, what are the future steps? What is the future scope? Where is AR VR going in the next few years, right? So I will track that journey. And at the same time, I will tell you a little bit about, if you need to start developing with AR VR, without getting too much into the technical specifications, because at the end of the day, I think there are more sessions planned over the next 5 days, which will go in depth into the technical details. I will just give a brief introduction to what are the technical details and what is required for you to start off with augmented and virtual reality. Okay, so just a little bit about us. Why are or just a little bit about Autoverse, which is where I currently work and which is basically our company. So why I'm even giving this context is to just tell you where our knowledge also comes from. So because VR and AR in general, as you know, is a fairly new field. It is the state of the art when it comes to a lot of technology being shown today. A lot of the things we are learning, a lot of the things that is happening in the industry. It is being learned with experience. So even when I speak today, I'm going to be speaking from my experience in the last 4 or 5 years of having developed for AR and VR in this industry. You might see this term called XR, which I will use occasionally. This is what the industry is using these days. Actually, it is this term is essentially called extended reality. Instead of using AR/VR as the bigger term, people just use the more condensed term called extended reality these days. And that extended reality essentially covers all forms of immersive experiences, whether it is AR or VR. So in our last 4 or 5 years, we have delivered more than 80 plus enterprise level projects for a lot of global brands. And it is from these experiences that we have learned a lot, and we have understood a lot about what works in the industry right now as far as extended reality is concerned. So what we do is we create 3D augmented reality and virtual reality experiences. We gamify a lot of these experiences to make it easy for the users to understand what they are doing. We make it more interactive and interesting for the users to explore virtual and augmented reality. Why do we do this? Very simple. There is a common saying these days. You will find it quite often written online. Essentially, it says, your couch is the new window to Wonderland. What does this basically mean? It is a little bit of a context here again, is that, especially in the last 18 months or so, everything has, a lot of things have moved to work from home. A lot of things have become remote because of the pandemic. People are no longer traveling as much as they did. People are no longer moving from point A to point B as much as they did. They would rather have everything available to them within the 4 walls of their house, right? Things are moving more digital. Things are arriving to the person as opposed to the person going to achieve that particular experience. So, when we say your couch is the new window to Wonderland, it essentially means that a person sitting in his living room, sitting in his hall with pretty much with a mobile phone or a laptop or any computing device is able to explore the world, right? That is all they require now. A simple hardware, could be your mobile phone, tablet, any computing device, is these days enough to connect you to the world. And AR and VR is making this experience richer. It is making this experience more interactive and more immersive, right? The AR and VR is it is essentially the next medium, right? We are in the transition from 2D to 3D, where a lot of the media that we consume these days over the last 15, 20, 25 years has probably all been 2D, whether it is movies, advertisements, any content online, it has all been 2D. The transition to 3D started a few years ago, and we are going there, where essentially all media is transitioning towards 3D and towards more immersive, interactive experiences. I think, as it was mentioned a while ago, we helped deploy one of the largest retail deployments for using virtual reality in the last couple of years. What essentially we did, to give you context, is that now assume a person has to buy some household appliance, right? In the status quo, what usually happens? You go to a showroom, you explore the devices, you see what devices work for you. Say you have to buy this dishwasher or washing machine, you will go to the showroom and you will try and you will look at how the device functions, and you will decide on whether you need to make a purchase or not. What is the advantage of VR here? What is the advantage of virtual reality? In virtual reality, a person can just literally wear this headset, right? With just this simple headset, you can transport the person from the world that they are currently in into a new virtual immersive world where you can literally create an entire virtual environment around that person. A person wearing this headset can see a virtual model of this washing machine or this dishwasher. you can create animations that take them inside the washing machine, that take them inside the dishwasher, show them how the appliance functions, show them how the washing machine washes their clothes, for instance, how the water jets help remove the dirt from their clothes. Anything, any kind of animation, any kind of feature that you want to display, it can be done in virtual reality, right? And the person can be scaled up or scaled down in that virtual environment and taken to any particular location in that environment, and they can see any kind of animation, any kind of virtual display that will show them something that is probably not possible in the real world, either because of physical constraints or because of unavailability of that particular device. But in a virtual environment, all of that can be created, all the digital information can be shown, and a much better immersive experience can be shown to that user. Similarly, that was VR. Now, what is AR, right? Just a brief description. AR basically is, I think it might have been covered in the last session. It is the overlaying of certain digital data, certain digital information on your real world feed, right? Whereas in VR, a completely new virtual digital environment around you is created. In AR, there is, you see the real world around you and certain additional information, whether it is in the form of certain animations, certain 3D models, certain, certain other general cartoonish figures like this, whatever it is overlaid on top of your real world, right? That is essentially augmented reality. You're augmenting the reality around you, right? So that is AR. Many of you might have seen on social media these days, people create all sorts of funny filters, all sorts of, sometimes they are even quite, quite silly, to be very frank. But at the end of the day, what do brands and what do companies and what do organizations target via social media? It is a little bit of hype. The aim is to achieve a little bit of virality. The aim is to somehow be a little engaging and interactive for the user. If on average a person can spend even 30 to 45 seconds using that particular feature on social media, that is more than enough for the brand, right? That itself is a big achievement. There is so much content on social media these days. If a person spends more than 30 to 35 seconds on one particular brand or one particular feature, that itself is a big win, right? So as you can see here, this data is from AC Nielsen, where basically they say that 93% of users who use AR filters, they on average spend more than 45 seconds engaging with that filter. That basically means that as opposed to having a simple poster or a brochure or any kind of regular 2D advertisement, if you have an interactive filter on social media, however silly it is, however seemingly inane it is, right? You have something interactive like this, automatically your engagement increases, automatically your brand gets a little bit of extra, viewing time or, TRP effectively in front of that user. So that is what they are targeting these days. And that is what technology companies like us are also trying to create these days. Now, why do I say all of this? I will come back to this slide again a little later in my talk, but just to give you an initial, feel, the common agreed knowledge these days, or common agreed upon idea these days, especially among certain viewers and certain, reviewers of technology, is that the virtual world will one day surpass the real world in importance. What this essentially means is that it comes from from two angles. One is from a commercial angle, and the second is from a user engagement angle. Essentially, what they're saying is that people will spend a lot more time interacting with the virtual world. People will spend a lot more of their energy and focus on the virtual world as opposed to the real world. And secondly, from a financial perspective or a commercial perspective, investments and money will essentially be redirected more towards efforts in the virtual world as opposed to the real world, right? We are already seeing this in a fairly big way, whether it is it is the growth of cryptocurrencies, whether it is the growth of NFTs, whether it is the way online streaming of various content, whether it is movies, games, sports, has increased exponentially in the last 5 to 7 years, right? All of this is happening. There are more people at any point in time. There are more people watching IPL on Hotstar as opposed to people actually going and watching it in the stadium, right? So these are all examples of how the virtual world is essentially surpassing the real world in importance. But again, we will come back to this a little later. So like I said, today's agenda, basically a little bit about the history of VR AR, and what is the current state of the art, and where do we go from here, right? If we want to start developing for VR AR, what are the basic 101 steps to follow, right? So this is what we'll be covering. And as I said, anybody has any doubts, please feel free to interrupt me and ask any questions. Okay. So in general, when it comes to technology, right, the saying goes that change can be immeasurably slow until it isn't. Essentially, what that means is sitting today, people may predict that certain changes are coming in the next 15, 20 years. And it may seem like this change is really, really slow, right? But until there is that one moment, that one particular kink in the graph, when that moment appears, when that moment happens, then change just moves exponentially faster, right? Generally, you will always notice a graph is a graph, or the graph of technological change is generally a plateauing, upward moving, but slightly plateauing curve. And suddenly when some particular event happens, that acts as a trigger and the change automatically accelerates and becomes an exponentially growing curve. That is generally what is noticed when it comes to, things like the Industrial Revolution or things like the automobile revolution, things like that, right? So one example for this is, how long did it take to get horse-drawn carriages off the roads in favor of automobiles or cars? So even until the early 20th century, people were using horse-drawn carriages, right? So this is the example. This is one of the busiest roads in New York. This was in 1900. Fifth Avenue is one of the busiest roads in New York City. Even today, it is one of the busiest roads in New York City. It was similarly, busy even back then, right? And as you can see, nearly all the traffic on the roads is horse-drawn carriages, right? You can see one solitary person there who is driving a car. It's highlighted in red, right? But literally all the traffic on the road is either foot traffic or people in horse-drawn carriages. Cut to a certain point in the future, right? The same Fifth Avenue, New York, no difference. It is the same road. Now try and spot even one horse carriage. All you can see on the road are even people who earlier used to walk about on the road are now sticking to the footpath, right? And all the traffic that you can see is basically automobiles, right? The Ford T model in most cases, but all of it is basically automobiles. How early or late was this? Well, sorry, just one second. Yeah, so this was barely 10 to 12 years in the future, from where it was in 1900 to where it was in this just 10, 12 years in the future. You can see almost all the horse-drawn carriages were taken off the road and they were replaced by automobiles. So that is how fast the change happened. All that was required was for Henry Ford to develop the assembly line. All that was required was for the Ford T model to become popular. And you could see that because of the sheer convenience, people immediately replaced their horse-drawn carriages with automobiles. So that's how fast technological change can actually affect what is happening in the real world. So just give me 1 second. Some issue with my screen share. Yeah, okay. So basically now, when it comes to VR, AR, right, let us explore the past a little bit. Let us see where VR and AR started from, right? Where did the concept of like immersive experiences start from? Right. So in the 1950s, there was this particular device called the Sensorama. Now, the Sensorama was not an electronic device, right? It was created by this person called Morton Heilig in the 1950s. It was, so sorry, it was not a computing device. It was nothing more than a gimmick, essentially. It was nothing more than a medium to essentially create an experience for the user that was beyond just watching 2D films, right? What did it do? Basically, it showed the person a 2D film, right? It placed that person on a chair, which was controlled by haptics and pneumatics. And it also had devices that gave out sound. It had a device which could emit certain smells, and the seat on which the person was seated reacted to things that were happening inside the movie. So basically, when the person put their head inside this particular device, as you can see here, something like this, depending on what was being shown on the film, the seat here that they were sitting on shook or reacted a little bit. There were sounds. Essentially, it was a very early version, if you want to say, a very early version of what these days in films they call Dolby surround sound, right? There's a very early version of that, where essentially all around the user there were certain speakers, and basic sorry, and sometimes depending on what was being shown, certain smells were also emitted to add further stimuli to the user. So this was a very early version of more than one particular sensor or more than one particular stimulus being used to capture the user's attention. So people thought in many ways this was an early imagination of what an immersive experience could be like, whether it was VR or AR. It was a very early interpretation of what an immersive experience could be like. In 1968, there was something called the Sword of Damocles. Now, if you look at this closely, this is not too different from, as you can see this image here, it is not too different from what a modern day VR headset is. When you think about it conceptually, right? It is a head mounted device, right? It is sitting on top of the person's head, basically. There are a couple of lenses which are acting essentially as, as either screens or projection lenses for the person, right? It is playing tricks on the user's retina, basically, which is essentially what VR and AR headsets do. They essentially play a trick on the user's retina. There is a wire leading back to a processing unit, which is like your wired VR headsets of today, like your HTC Vive or Oculus Rift, are VR headsets that are connected to a laptop where the processing is outsourced to that particular device, whether it's a laptop or a desktop. So similarly here also there is a wire leading out to a particular processing unit, right? So in many ways, it is not too different from a modern day headset, but a very, very early version of that. So let me just play this video and you will kind of get an idea about what I'm talking about. So as you can see, the person is moving around their head while wearing this headset. And as they are looking around, basically certain virtual objects are spawning in front of them. So now you will see. Yeah, as you can see, this is the user's point of view. You see that here he can see something like a very, very simplistic, a very, very primitive version of a cube, right? Of a six-faced, polygonal object, essentially, right? And you can see here that he's looking at a very primitive version of a cube. And this is actually his real world around him. So in many ways, this is an early version of augmented reality, where on the real world around that person, certain additional digital information is being overlaid, right? In this case, it is a very primitive cube, but nonetheless, it is still basically augmented reality, right? Yeah. So when I say that, why do we call this an early version of VR or AR? When you think about it, the components on this particular device, right, are essentially very similar to what is there in your modern day VR or AR headset, right? Whether it is a sensor to track the head position, right? Even on your modern day VR headsets, if you look at the HTC Vive or the Oculus Rift, right, you'll see that they have like small sensors inlaid on the front panel. So all of this basically track the person's head position, right? When the person moves their head either to the left or to the right, when they move it up or down, right? Essentially what is happening, there is a particular screen in front of the user, correct? And as they move their head up or down or left or right, the frame that is being rendered on that particular screen, on that particular display, also has to automatically change. Because as a person is moving their head left or right, essentially their eyes should now be seeing something different from what they were looking at when they were looking at straight. That is the only way that the brain will be convinced, or the brain will be tricked into believing that it is in a new environment. If you move your head left or right, but what you are seeing in front of you does not change at all, immediately you are snapped out of that particular immersive experience, because you will realize that basically it is, it is make believe. But if your brain is convinced into seeing, new frames and new visuals every time you move your head left or right, it convinces your brain that you're in a virtual environment, that you are in a different environment, essentially, right? So this is basically what this device was doing. There was a head position sensor to track whether the person was moving their head left or right, essentially like a modern day gyroscope, right? Whether it was moving their head left or right, or up or down, or backwards, forwards, so on and so forth, right? And based on that, it was changing, what was being shown to the user a little bit. Similarly, there was a vector generator which essentially tracked the person's movement inside a small 3D space. In modern day VR headsets, you will see that for whether it is a HTC Vive or Oculus Rift, you will find that there are external sensors, right? They're called base stations or lighthouse sensors or so on. They have different terms. But essentially what they do is they interface with your headset, right? They triangulate your position inside 3D space. As you're moving around in the real world, it tracks your movement and maps that movement into the virtual world as well, right? That is essentially what these positional sensors do. So in a way, this early primitive headset also had a vector generator which helped triangulate that person's position inside 3D space, right? And there was a computer as well where all the processing for all of this was done, right? There was a wire from this headset that led to an early server or an early processing unit which could perform all these calculations and in turn relay all these instructions through the VR headset. And it was also an early version of augmented reality. Why? Because as I showed in the video, on top of the person's real world feed, it was overlaying certain digital information. So basically, it was also an early version of augmented reality. Now, the first time this term called augmented reality, at least so far what people have discovered, the first time this term was coined was in 1992, right? And like a lot of technological developments, or a lot of cutting edge technological developments, this was also done in the field of, defense and, weapons research, whether either fortunately or unfortunately, a lot of the technological developments these days are done in, are invested or done in that area. So, similarly, even augmented reality was first coined, or the term was first coined by this person called Thomas P. Cowdell. He used to work with Boeing Computer Services. And on behalf of the US government, he produced a research paper where essentially he theorized a head-mounted display or a head-mounted device which could overlay certain information for users. In this case, the users were basically Air Force pilots, right, or fighter pilots. Now, typically, some of you might have seen what a typical Air Force or an airplane cockpit looks like, right? There are 100 different panels in front of the pilot. There are so many different control systems. There are so many different panels that they need to look at and understand certain information and then translate that into particular actions. Now, this person, basically Thomas Cowdell and his fellow researcher, theorized a headset, or theorized a head-mounted display which could integrate with the pilot's helmet and relay all the information within just that pilot's helmet, right? Without having to look at 100 different screens or 100 different graphs or radars in front of them. All the information was very succinctly put in terms of projections, where essentially the pilot's helmet is itself converted into an augmented reality headset, right? So this was, in a way, the first time this term augmented reality was coined. Similarly, in the year 1992 itself, in the US Air Force Research Laboratories, someone created this device called the virtual fixtures, right? It was developed by the AFRL in 1992, or at least the information was publicly given in 1992. And it was one of the pioneering platforms for VR and AR. As you can see, one of the interesting things about this, something that was probably not there in any early version of VR or AR, was the fact that it had input devices. So till then, whatever version of an immersive headset was created, there was no way to provide any hand-based input, right? Any user-based input to whatever they were seeing, right? It was not exactly interactive. Certain things were happening and they were seeing it happen, but it was not really interactive. So this is the first time there was some hand-based input, right? These controllers that you see this person holding, they may look very complex and they may look like robotic arms, but essentially they were nothing more than hand-based input to the particular, experience or application that was happening in front of them. All of these are essentially sensors to track the person's hand movement, right? Now, I think this was also covered a little bit in the last talk, but a very, very early version of, or an early application that people theorized, and this was purely in theory, that people came up with for, augmented reality or virtual reality headsets was actually within the field of, was in the medical field, where, if a doctor had to train or a professor of medical sciences had to train their students on how to, say, perform an autopsy or how to perform a very complex surgery, right? They don't always have like a cadaver, or they don't always have a human body in front of them on which to show these kind of tasks or experiments, right? So what VR or AR could do is that essentially, if everyone is wearing this VR headset, right, they see a completely virtual version of the human body in front of them, right? All the information could be overlaid on top of that virtual body, and the person can perform and get trained on certain medical tasks and get trained on certain medical protocol while just performing that function on this virtual body. That is one thing. The second is, of course, augmented reality, where if you have a real body in front of you and you need to perform a particular surgery or perform a certain medical intervention, information is overlaid right in front of you, right? On top of that body, certain information is overlaid. It tells you where exactly to perform the incision. It tells you where exactly or how much pressure to apply on a particular point. All of this information is overlaid on top so that the surgeon or the particular medical practitioner has all the information that they need. Now, of course, this was all purely theoretical. It was theoretical in 1992. It is quite theoretical even now, to be very frank, because there is no confirmed large-scale deployment of using VR AR in the medical field, to be very frank, because of course it needs to be really precise and needs to be really exact before something like this can be deployed in the medical field, simply because the stakes are so high, right? So, but theoretically speaking, this was one particular use case for extended reality, even as early as 1992. Now, these were all applications in maybe on the business side, or for organizations. Now, from a consumer perspective, between the years 1987 to 1992, as you can see here, there were a few VR headsets, especially head-mounted displays, effectively like this, that came out in these 5 to 6 years. But a lot of people categorize these as a false start, right? A lot of headsets came out, but there were several challenges and several roadblocks since these weren't exactly user-friendly, right? One particular headset that came out, it was developed by, if I'm not mistaken, it was developed by Sony, either Sony or Nintendo, right? This particular headset was created in 1987, right? And it was nothing more than a simple video game player, right? There was a screen here, which was in front of the user. It mounted on top of the user's head. There were obviously headphones connected to it. And there was a wire leading out to some kind of a processing unit, which might have been an early mainframe computer from the 1980s, right? And this headset, quite ironically, was called the iPhone, because it's settled in front of the user's eye. It was called the iPhone. It had absolutely nothing to do with the modern day Apple iPhone, but rather ironically or rather funnily enough, it was also called the iPhone. Now, why was this unattainable for the user? Aside from all the technological limitations, which I will come to in the next slide, it was also extremely expensive. As you can see here, even a very, very early, primitive version of it was as costly as $9,500. This was in the early 90s, so you can imagine how expensive it was. A slightly better version, a slightly more advanced version called the iPhone HRX was as much as $49,000. And if you can see what this person is wearing here, these are essentially, this is essentially a glove padded with certain sensors to track the user's fingers and to track their hand movements, essentially acting as nothing more than a handheld input device, kind of analogous to the mouse or the cursor that we have right now. But as you can see, that glove that they are using, the glove with sensors, even that was as expensive as $9,000. So the entire unit put together would be something like $58,000 to $60,000, making it extremely unattainable for a regular consumer to buy, right? And even if you're spending $58,000 to $60,000 on a particular device, you still the least you can hope for is highly unlikely that anyone would spend it. But even if they did, the least they should hope for is that it will have enough features, it will have enough applications that make it useful. But of course, at that time, unfortunately, there were hardly any applications for it. There were also other companies, as you can see, as you might recognize, most of them were video gaming companies from the early 90s. Of course, many of these companies are still around, but all the use cases for VR and AR early on were clearly, people thought that they would primarily be used in the gaming industry. So Nintendo, the Japanese, video game maker, famous for, of course, famous for games such as, Mario. They came out with this thing called the Virtual Boy Classic, right? Which was, of course, much cheaper. It was just $99.99, but still the kind of features on it and the kind of applications that it could support were very, very minimal. Similarly, Sega, another competitor, another competing video game manufacturing company, came out with this headset called Sega VR. But all it could play was just this one game, which was essentially a wrestling game. And it had a very limited, bandwidth in terms of users and use cases, right? Now, this particular headset, as you can see, it had no head tracking. Whether you moved your head left or right or up or down, it showed you the exact same frame and showed you the exact same images. It had only a red and black display, so no color, even though color television and color screens were available for several years before that. It was not able to integrate a color display in front of the user. It was just a red and black, like an early DOS system. The games were very poor, hardly interactive, hardly engaging. So, because of all these limitations, basically it had very little traction with consumers. It had almost, no traction among consumers. And within a few years, Nintendo had no option but just discontinue this headset because it wasn't really doing anything in the market. Now, for those 20 odd years, until 2012, just because virtual reality was not that accessible to, the consumer, does not mean that there was no development happening in the background. For a long time, for about 2 decades, a lot of incremental development was happening, but all of this was restricted to the industry, and even in the industry, extremely niche and specialized industry. As you can see here, these are essentially Air Force pilots who are getting trained on a virtual cockpit system, right? And until 2012, this was mostly the state of the art, where only people who could actually afford to invest hundreds and thousands or even millions of dollars on sophisticated complex systems, only they could actually afford to do this, right? This entire unit that you see here, this is actually taken from Dassault, that is the French company, DASSAULT. On a side note, also the same company which produces the Rafale, fighter planes. But yeah, this system is from Dassault, and basically what it does is, create a virtual cockpit where pilots can get trained on literally whether it's the basics or the most complex part of fighter pilot simulations or fighter plane simulations. You can create all those simulations and train the pilot on it. And in fact, even right now, the industry standard is for pilots is to achieve a certain level of comfort and fly a certain number of hours on these virtual flight simulators before they actually progress to flying a plane in real time, right? So there is this is quite a mature thing in this industry right now. Even if using a virtual reality headset is still fairly new, using some kind of a virtual simulation for flying has been in the industry for quite some time now. Similarly, what you see on the right side here is something called a CAVE system, CAVE, CAVE. This is also a system that costs like anywhere about $250,000 to $300,000. What this essentially does is it places the user inside a green screen room. So actually what you're seeing all around the user here is nothing more than a green screen. And similar to how animated movies and how visual effects is done in high-end animation using green screens, certain virtual renderings and certain virtual information is relayed on these green screens to create the perception that the user is inside a new virtual immersive environment, right? So this is something called the CAVE system, right? But even this is extremely difficult for a common man to purchase or utilize, because like I said, the investment required for setting something like this up is anywhere north of 250 to 300,000 US dollars, going up to millions of dollars, right? So what changed after that, right? What is the present day world like post 2012, and why in 2012 specifically did things change so much, right? So basically in 2012, this company called Oculus started, right? There was this one enterprising young chap called Palmer Luckey. He's the person here in the center, this person here. That is Palmer Luckey. What he essentially did was he created the prototype for the first ever Oculus headset. Now, most of you attending this talk by now would be familiar with the term Oculus. Oculus right now is a company owned by Facebook. But they created what is the early prototype of the first ever modern day virtual reality headset. And when I say first ever, I say because it was the first ever headset in the modern day setting in the last 10, 12 years, which was actually accessible to the consumer, which was at a price range where a consumer could buy it, where development and creation of independent applications and independent software for that particular headset was attainable for the common man, was attainable for even an indie developer sitting at home, right? All of this was made far more easier thanks to Oculus coming on board in 2012. In 2014 was when the real hype began for VR. Why? Because Mark Zuckerberg, by that time itself, had realized that the next, like I mentioned early on in my talk, the next medium is VR AR. So this is something maybe Mark Zuckerberg realized in 2014, and they invested, or rather spent, $2 billion in acquiring Oculus. At this time, Oculus was nothing more than this simple headset here that you see. Right, it was a very early development kit, and that was enough to convince Facebook to acquire them for as much as $2 billion. If someone is really interested in how Oculus started developing this particular headset, what was the inspiration for them to do so, and what early technologies did they employ in the early 2010s to create this particular headset, there is this nice book called History of the Future. It is by this person called Blake Harris. If you want, after this talk, I can post the Amazon link also to that particular book. It's a pretty interesting take on how the first technological advancements for creating a modern day VR headset were done, and what challenges they faced, more importantly, right? So I would actually encourage anyone who's interested in this particular topic to read this book. So from 2014 to 16, they brought out two headsets, but as you can see by the names itself, they were DKs, that is development kits. So they were not full-fledged consumer headsets yet. They were still releasing these as development kit 1 and development kit 2. In 2015, the development kit 1 came out, 14, and in 2016, the Oculus Rift development kit 2 came out. These were, very fairly primitive compared to, even the headsets that you have today, barely 5 years later. But still, they were accessible and attainable for the consumer. And there were a lot of independent developers and small gaming studios and small video game companies, like even our own company, which bought these headsets and tried to create applications and tried to convince large enterprises that there are legitimate, meaningful use cases that can be solved. There are legitimate, meaningful business requirements that can be solved using virtual reality. The real boom, of course, happened between 2017 to 19, when the first generation of VR hardware came about. Many of these headsets are also still available in the market, although some have been, of course, for quite a few of them. We already have the next generation of hardware, so it doesn't really make sense to purchase these now. But still, these are still working perfectly fine. And for entry-level VR, these are still really, really good headsets, right? Whether it is the Oculus Rift, the HTC Vive, or the Sony PlayStation VR. As you can see, all of them have some standard features. That is, they're all head-mounted, right? All of them essentially, when you think about it in terms of functionality or in terms of framework, they are nothing more than a very powerful display or a phone which is mounted in front of this particular in this headset, in this portion of the headset. There are two lenses, right, which essentially perform the task of polarization, as the professor in the previous talk was explaining. There are two polarizing lenses which are present here, which rest next to the next to the eyes of the person when this particular headset is worn, and they focus the person's eyesight, and they focus the person's view on what is happening on the screen in front of them. The screen, of course, is mounted in this front portion of the headset. That is the standard hardware setup for any of these headsets. There is a screen in the front. There are two polarizing lenses which are present at the back, and those polarizing lenses rest in front of the user's eyes when they wear this particular headset. Early on in my talk, I mentioned that there are head sensors. So on this HTC Vive, they are very, very obviously seen. You can see all these depressions here that you see on this headset. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are overall 12 depressions that you can see here, right? 6 large ones and 6 small ones. These are nothing more than a combination of Bluetooth sensors that pair with these particular base stations. On the left and right, you see 2 rectangular boxes here. These are mounted diagonally opposite each other in a particular room. In any room, you mount these sensors diagonally opposite each other, right? And they pair with this headset via standard Bluetooth framework, right? Your standard Bluetooth communication framework, they pair with these with this headset, and they track the user's movement in that real space. In that particular space, they track the user's movement and they triangulate that person's position by tracking the movement of the headset. That movement is mapped into the virtual world. So as I move around in my real world wearing this headset, my movement is mapped 1:1 in the virtual world as well. So if I move 3 steps to my right in the real world, that exact 3 steps to the right is tracked in the virtual world as well. So as I keep moving from, say, left to right in my real world, in my virtual world as well, I'm moving an equivalent distance left to right. And consequently, when I do that, what I see in front of me, the image being rendered in the screen in front of me also changes, right? That is essentially the task performed by this VR headset. Similarly, there are handheld controllers. On the Rift, you will see a slightly different physical design. And on the Vive, these are essentially called wand controllers. You hold them on this long stem here. In the Rift, you hold them similar to how you hold, say, an Xbox controller. It is kind of analogous to that, actually. On the Vive, you hold them along these long stems. Both perform the similar task of helping the user provide certain input, right? You can, as you hold these wand controllers or these Oculus Touch controllers, you can perform certain interactive actions inside the virtual space. you can actually, as you can inside your virtual space, you can program it so that if the person touches something with that particular controller, certain actions happen. So if I need to train the person on, say, how to pick up something in the virtual world, as the person reaches out with their hand to touch something, you can show an animation where a hand is grabbing that particular object. So things like that. Essentially, you can, using these input devices, which are essentially these controllers, you can create a completely interactive virtual experience. Right. And in a PSVR, of course, this is more built for a gaming perspective. PSVR is nothing more than PlayStation VR. So it actually interfaces with the Sony PlayStation, video game setup. And the input device here is nothing more than your PlayStation controller, right? So in all these cases, of course, the processing does not happen in-house. The processing is outsourced using essentially a wire from this headset will connect to either a laptop or a desktop, right? And the processing is outsourced essentially to an external computing device, whether it's a laptop or a desktop, or in the case of a Sony PSVR, it is connected to a PlayStation device. All the processing required in terms of how much in terms of how the image being rendered on this particular screen needs to be shown, what image needs to be rendered on this particular screen, at what resolution, so on and so forth. All this processing is done externally, and the instructions are relayed back to the device, to the VR headset. So this VR headset acts as nothing more than a head-mounted display, and all the processing is done externally on an external processing device. Now that was virtual reality. In AR, right, what were the changes that happened after 2016-17? Even here, right, a lot of hardware changes essentially made it far more accessible for the user, right? The biggest one, of course, was because of both Android and iOS. That is the two largest operating systems in the mobile computing market these days, which are obviously Android and iOS. Both of them started heavily investing in AR. I will again show it in a few of the later slides, where basically Google has its own setup called AR Core and Apple has its own setup called AR Kit. And both of these are inbuilt frameworks or inbuilt plugins on most of the modern day and Android or iOS phones or tablets that you buy these days. But these essentially allow your particular phone or tablet to support augmented reality. Right. And because essentially that augmented reality functionality comes inbuilt on most of our phones and tablets these days, it becomes so much more accessible for the user. Right. The person does not need to spend anything extra to have that initial introductory experience when it comes to augmented reality. There are certain, of course, head-mounted devices also, which are a little more expensive and hence not particularly suitable from a consumer perspective. You will essentially the Windows mixed reality device. Mixed reality is a bit of a misnomer here. It is for all intents and purposes, all practical purposes, it is mostly a VR headset. It does have one particular feature that makes it a little bit of an AR device, where essentially it has a pass-through functionality where the two cameras here in front of this headset, they allow you to see the real world as well. These cameras essentially scan the real world environment and relay it back to the screen that is there behind it. So you can actually see the real world environment as well. So that kind of converts it to an AR headset, but for all intents and purposes, for all practical applications, this is mostly a VR headset. The HoloLens and the Magic Leap are two devices you might have heard about, or you might have come across quite a bit in modern day context. And both of those are fairly powerful AR headsets. The only problem is that, of course, they are a little, commercially unavailable or unattainable for a modern user, at least at scale, right? When I last checked, the HoloLens, I think, was about almost $3,000, right? And the Magic Leap is around $1,800 or $2,200 or something like that, depending on where you buy it and how much and what all features you go for. But like I said, it is still fairly expensive for a modern consumer, especially someone sitting in India. It is a significant investment, right? So they are not yet that attainable from a consumer perspective. The most accessible form of AR, right? The most accessible, meaningful, and scalable form of AR right now. It's a no-brainer. It is essentially the simple phone or tablet that you have in front of you. Right? That itself is your AR device right now. In 2016, basically, many of you might have come across this particular game called Pokemon Go was released by this company called Niantic, right? Niantic, Niantic. They released this game called Pokemon Go. Now, what did this game do? It was essentially a geospatial tracker, if I had to call it that. I'm not sure whether my definition of it is exact, but what it basically did was you could carry your phone around, open the game, and on the real world in front of you, it essentially spawned these Pokemon. Pokemon are nothing more than certain cartoon characters, right? It created 3D versions of these Pokemon and enticed people to go and catch them. So you had to essentially run behind this particular, Pokemon and capture it on your phone, right? And as you can see, this is the very definition of augmented reality, right? There is a chap standing here in the real world, right? There's a person standing here, and there is actually digital information being relayed on top of the real world feed. Now, the person holding this phone is seeing the feed of this person standing here. And in addition to that, there is certain digital information, which in this particular case is a cartoon character, right? So that is basically, the very definition of augmented reality. And this particular AR game went really, really viral. Even in India, it had a lot of traction because it was a very simple game to download, a very simple game to install, and people were able to play it very easily because almost most phones which of a certain price range and above could support augmented reality. They had inbuilt AR functions and they could support this game and they could easily play it, right? It was that easy for this game to scale up. So it went pretty viral. And so on and so forth. A lot of brands also started picking up AR day in and day out. I think I showed this slide a little earlier during my presentation as well. But because AR became so attainable, right? And if my memory serves me right, what was last estimated, I think by either a Forrester or an AC Nielsen survey, is that about 85% of the smartphones in the market right now, in terms of volume and usage, about 85% of the smartphones in the market right now can support some form of augmented reality, right? And this is because essentially both Google, which produces Android operating system, and Apple, which obviously produce the iOS operating system for its own phones, right? They both have invested fairly heavily into creating augmented reality enablers, right? Which is essentially AR Core for Android and AR Kit for iOS. These plugins are automatically integrated into your off the shelf. They are integrated into your devices these days. And most of the phones, any phone that you buy in the market these days, which is probably priced in the 10,000 to 12,000 and above price range, right? They come inbuilt with a gyroscope, and along with that, they are also inbuilt with AR Core or AR Kit, depending on which phone you buy, and they can support some form of augmented reality. So company, and also consequently, there are content generation companies like your social media companies like Snapchat or Facebook or Instagram. All of these essentially are trying to get more user engagement, obviously. And all of these silly filters, all of these silly face masks and so on that you see are, nothing more than, augmented reality, right? The front camera of the phone is recognizing the person's face, and on top of that person's face, it is overlaying certain information, whether it is in 2D or in 3D, it is overlaying certain information on top of the user's face. Right? And this is basically a very, basic version of augmented reality. Right? Now to just give you an example of how much this particular landscape or this particular, technology has grown in the last, several years. So this was in 2016, right? And even back then, you can see there are so many companies which had invested heavily into this, right? Whether it is in creating certain specific niche VR and AR applications, right? Whether it is in facilitating the framework and the system to create these applications, like Google, Apple, and so on, facilitated the frameworks for creating these applications. Whether it is companies that created either the engines or the hardware necessary to create AR and VR experiences, companies like NVIDIA, which creates graphic processing units, companies like Unity and Unreal Engine, which give you game engines for creating these kind of experiences. We will of course talk about these a lot more in the next few slides. Whether it is hardware manufacturers like Oculus and Sony or Valve, which are creating these headsets, right? There were quite a few in 2016 itself. It was a pretty crowded market, right? Now, if I just jump to 2019, right? 18 and 19, which is barely 3 years down the line, you can see how much more crowded it is. Look at how it was 5 years ago and look at how it was 2 years ago. And now if I update this, I unfortunately don't have the updated chart for 2021, but I can tell you it will probably occupy the entire screen, and I'll probably need one more slide just to mention all the companies that are doing something interesting or doing something revolutionary in AR and VR right now. That is how quickly this field is growing, and that is how fast changes are happening in this particular field. So this is something called this particular graph that you see in front of you. Now we are in 2021, right? And this particular graph you see in front of you, something called the Gartner hype cycle, which is basically, the graph is theorized or conceptualized by Gartner, the company, which essentially, Gartner Research. And this is essentially their graph for any innovative technology or any game-changing technology, right? According to them, according to their research, this is basically the graph it follows for as part of its life cycle, right? So it's called the Gartner hype cycle, HYPE hype cycle. Now, what does this graph mean? There is always an initial trigger, right? The graph is expectation, which is basically user expectation or the expectations of the market versus time. So there's always a trigger when initially people start create the technology, or when people explore the technology initially. There is always a lot of hype. There is always a lot of expectations. And like everything, these expectations tend to be a little exaggerated. These expectations tend to be a little overhyped. And this is probably what happened to AR VR in the early 90s. So as I told you, in late 80s, early 90s, there was a false start for AR VR, right? That is because expectations went sky high, but unfortunately the hardware and the software simply not picked up to the level where they could meet these inflated expectations. So it peaked here. And then of course, immediately when people realized that the hardware and software had not come to the standard that they had expected, there was a huge disappointment, right? It's called the trough of disillusionment. So it collapsed almost immediately after that in the next 4 or 5 years. Then slowly, ever so slowly, people started once again looking at the technology from a more mature angle. They started understanding that, let us pare down our expectations and let us develop responsibly, right? Let us see where the hardware is at currently. Let us see what the state of the art and the software is. Are we able to match the necessary, applications that we can develop, right? Do we necessarily have the hardware in place to produce these kind of applications, right? So one of the biggest roadblocks in AR and VR, to be very frank, is processing power, right? How do you, the amount of graphics processing required, or the amount of instructions that a graphics processor is required to process to produce high quality VR AR is immense, right? So you need to essentially pack a high powered graphics processor into your computing device to be able to produce good quality VR or AR. Now, to do that in a meaningful way, you need to be able to pack a high-powered GPU inside a phone or inside a small VR headset, right? If you don't want a bulky laptop or a desktop always connected to your VR headset, you need to be able to package that kind of graphics processing power into a small surface area, whether it is a phone or a VR headset. Now, essentially, the hardware needs to keep continuously catching up to be able to facilitate this kind of, to be able to facilitate high fidelity VR. So essentially, that is what is happening right now, which is the slope of enlightenment, where people are there are companies simultaneously developing the hardware. Companies like NVIDIA, AMD, Qualcomm, all of these companies are working together to create the necessary hardware to facilitate the software developments that are happening in VR and AR simultaneously. So we are slowly moving towards this path called the plateau of productivity, where essentially the technology is in place, the ecosystem is in place for creating meaningful experiences and meaningful uses of the technology itself. So now one common term that many of you would have heard about or read about online is this term called the metaverse. Now, what is the metaverse? There are several. If you just Google it, you will find like 100 different definitions. You will find 100 different people having their own explanation as to what the metaverse is. And just 3-4 months ago, Mark Zuckerberg basically put out a statement. I think it was during Facebook's annual developers conference, if I'm not mistaken, where he said that Facebook want to be the pioneers in the metaverse. So right now, the metaverse is not necessarily restricted to AR and VR. Like I mentioned earlier, AR and VR is going towards becoming the next medium. But essentially, anything that is happening on the web, anything that is happening in the virtual world, any experience or digital property that is there on the digital world is part of the metaverse, right? It is essentially, it constitutes what is broadly believed to be the metaverse right now, whether it is all your online games, whether it is your social media channels, whether it is your content creators or content facilitators like Netflix, Amazon Prime, Hotstar. All of these are creating certain functionalities where they are allowing the user to have certain interactions, allowing the user to have certain experiences in a digital framework, in a virtual world, right? All of these broadly constitute what is known as the metaverse right now. In a very abstract way, the World Wide Web, right, WWW, the internet as we know it today, is itself the primitive version of what will become the metaverse in maybe 10-15 years in the future, right? The internet as we know it is going towards a point where everything from 2D is converting into 3D. And I think that is where essentially the realization of the idea of the metaverse will actually be seen. You will find things like, people throwing around terms like blockchain, AI, ML, AR, VR, everything tends to be coagulated into this one particular, word cloud, right? People just throw around these terms, but broadly, in a way, there is a growing, assimilation. There is a growing, mutual symbiotic relationship that is coming on between VR, AR, and between NFTs, and consequently the blockchain network. All of this is slowly happening, where people independently developing for each of these technologies are realizing that all these technologies can kind of work together. There are artists who are creating digital art, and that is being put on the blockchain, framework to establish their, provenance. There are real world performers. There are real world, content creators and performance artists who are, instead of performing concerts in stadiums these days, are creating virtual versions of themselves and performing concerts inside games, are performing concerts inside large large virtual worlds, right? There are people trying a lot of interesting things. Fortnite, for instance, is one of the probably one of the most popular games, cross-platform games in the last 2-3 years. Fortnite and PUBG. I'm sure a lot of you would have heard about PUBG, right? So these are probably the two of the most popular games that have come out in the last 2-3 years. And simply because they are compatible with smartphones. Anyone with a smartphone, sitting with a smartphone right now, can either play PUBG or Fortnite. You can join a vast virtual world where there are millions upon millions of people playing this game and interact with someone sitting on the opposite side of the planet. You can interact with them. You have vast virtual worlds created where where you can just go and play some games. This particular person called Stormzy, he's actually a pretty famous rapper / hip hop artist. He actually conducted a full concert inside Fortnite, the game. So people could log in to play Fortnite, connect on a particular IP, and just jump into that world, and they would actually see a full 2-hour concert by this rap or hip hop artist being performed inside that virtual world, right? So this is how technology is getting to the point where I earlier mentioned that the virtual world will one day surpass the real world. It is kind of getting there, right? We may not see it right now, maybe not in the next 5 years, 10 years, but definitely in the next 15, 20 years, we are getting to a point where we have definitely hit that inflection point, right? In the growth of VR, AR, and in the growth of virtual technologies. So, which is essentially why I, mentioned what I said earlier, that the virtual world will surpass the real world in importance. May not happen today, may not happen tomorrow, but we are getting there. And it is important that we prepare ourselves for that kind of a situation. So, just give me a minute, please. I'll just get some water. Okay, so now as developers or as people who want to create experiences in VR and AR, right? Give a pretty long introduction to VR AR, but as people sitting here who want to create something in VR AR, who want to develop certain applications in VR AR, how do you start, right? Or how do you even track all this progress, right? It's very simple. Just follow the hardware. The software will always be there, but it's the hardware that essentially facilitates these interactions, these experiences, right? You follow the changes in the hardware. You essentially follow how GPUs and processors are improving on a day-to-day, week-on-week, quarter-on-quarter, year-on-year basis, and you will essentially be able to track the growth of VR AR in the modern day context. I'm sure everyone sitting here has come across Moore's law. Which dates back to, I guess, the 1960s. But the Moore's law essentially, conceptually, it just theorizes how much processing power and how many instructions can potentially be conducted on a computing device given a limited amount of surface area, right? Broadly, that is the concept, right? So you follow, you follow Moore's law. You essentially kind of arrive at what is the progress of VR AR in the modern day context. Of course, as we move to newer forms of computation, newer forms of computing, these things can only improve and can grow much faster in the coming days. Yeah. So essentially, right now we are at a juncture in VR and AR where we are at the cutting edge. When I say the cutting edge, let me just give you an example, right? So now what you're seeing on this right hand here, on this right hand side, the person is on an e-commerce website, right? He's looking at a particular flower vase in an e-commerce website. Now all he's doing is he's clicking on a button saying, take me into AR, right? So he's not even installed an additional application on his phone. On his phone browser, this looks like an iPhone, so probably the Safari browser or the Google Chrome browser. He's basically looking at a particular e-commerce website. He's not installed any additional application on his phone, so even that barrier to entry is not there. All he's doing is just clicking on a button saying take me into AR, and immediately the browser gets minimized, and or within the browser itself, right, the phone's back camera is activated. the real world feed, which is probably the person's living room or a dining table in front of them, turns up because that is what the camera is seeing. And a virtual version or a 3D twin, a digital twin of that flower vase spawns in front of that user, right? And recognizes that there is a hardwood table here, and it keeps the flower vase on that table. So just without installing any additional application, without installing any additional requirement, by just a click of a button, the person is able to visualize how this flower vase looks inside their house. So that is essentially how usable and how scalable and how attainable VR AR has become, or AR specifically, augmented reality has become in the modern day context. This particular technology is something called WebXR. I will talk about it a little bit in the next few slides, but essentially that is how easy it has become. Sitting in the comfort of my home, at a click of a button, I can visualize how a 3D object looks like inside, right? Sitting in the comfort of my home. And this is where we are at the cutting edge of, VR and AR right now. And it is this cutting edge where all the action is. When I say all the action, all the technological advancements, all the incremental improvements in visualization, all of that is happening in this cutting edge. And consequently, this is where the profits are also to be made. So in a way, whether it is rightly or wrongly, the market is driving this particular technology right now. And the market will move towards, the point where most profits are to be made. And that is where the technology is also growing, right? Whether it is right or wrong, that is the way it is being driven. And that is where we are heading, right? Now, to match this frenzied pace of VR AR development, right? What are the softwares or the tools that we need to use? So broadly for VR specifically, and also to some extent AR, especially if we are talking about device-based VR AR, right? Whether it is for headsets or for smartphones and computing devices, most of the standalone VR and AR applications that are being built using game engines, right? And when I say game engines, don't necessarily confuse them with just video games. The game engine is just a terminology. That is because the two game engines that I will introduce to you in the next few slides started with the motive of helping video game developers. But very soon it was discovered that, of course, they are outstanding platforms for developing video games, but they also have applications in industries that have nothing to do with gaming, right? So you will see that going forward. But essentially, these are called game engines. And they are both fairly mature. They are both fairly mature development environments and can help you create some really nice VR and AR applications. So basically, there are two of them. That is, one is Unity and the other is Unreal Engine. I think a little bit about both these, development engine or these game engines, you will hear about a fair bit in the next 4 or 5 days. Especially, I guess, Unity, because it's a little more, the barrier to entry in Unity is a little less compared to Unreal Engine. But broadly, both Unity and Unreal Engine have like huge applications, especially for VR AR. They are the standard go-to go-to development platforms for creating any kind of VR or AR applications. For the web, when I say on the web, basically what I showed in 2 slides prior, right, where you can integrate a VR or an AR or especially an AR experience into just a simple browser-based, experience, right? So this is something called WebXR, as I mentioned earlier, where without having to install a standalone application, you can have a very early, very meaningful AR or a 3D experience, right? So that is essentially something called WebXR. For this, there is largely only one standard in the world right now, and it's a brilliant piece of technology called WebGL, right? The development languages or the development frameworks for this are essentially something called React.js and Three.js. Now, you might see a lot of computer science students or computer science engineers who are these days specializing in the React framework or the React stack. So React is essentially, again, a programming language based out of JavaScript. It is built on JavaScript or on the JavaScript framework, and it helps you develop certain VR AR applications Among other things, it helps you develop certain VR AR applications which can be integrated into websites, which can essentially can be distributed to users with nothing more than just a simple website URL, right? Just like how a simple link was distributed to all of us to join this particular Zoom call for today's sessions. Just distributing a simple web URL, a simple link, you can give them an introductory experience into VR or AR, right? It is nothing more than a 3D website which is built on that particular link, which is accessed via that particular link, and that can be built using technologies or frameworks such as React and Three.js. Now, when it comes to VR development, I say the bedrock is Unity only because they have a bigger share of the market right now, and they are a little more attainable. Like the hardware specifications are a little more, simpler for Unity, for you to install Unity and start using it. That said, this does not mean that I'm writing off Unreal Engine. I will also talk a little bit about Unreal Engine in the next few slides. But Unity is probably has a slightly bigger market share simply because they're a little more attainable right now. And it is about 90% of HoloLens experiences, at least in the last few years, have been created on Unity because they have slightly better SDKs and slightly better plugins when it comes to creating VR or AR experiences. That's the only advantage, right? Now, what exactly is Unity? Like I said earlier, it's a video game engine, right? It is an engine or a development platform that was created specifically for video games early on. But of course, now, although it is heavily used in creating several games, it is heavily used in the gaming industry. In the non-gaming industry as well, Unity is standard for creating several 3D experiences, several interactive 3D frameworks, several mobile applications. And of course, for VR, AR, Unity and Unreal Engine are, like as I said earlier, the go-to platforms when it comes to creating any VR, AR applications. Now, what does Unity do? It essentially helps us manipulate certain 2D and 3D models and certain 2D and 3D assets, or essentially 3D data using code. And this code on Unity, at least the framework is basically .NET or C#. It is essentially a very simple .NET or C# framework. Unity itself is built on C#, and of course to perform these manipulations and to perform these particular to write the code for these particular interactions, you would write it on a C# platform, right? And all the graphics is rendered using different graphics APIs depending on which device you are particularly using. For Windows, it uses the OpenGL framework. For Android, it uses the ES 3.1 framework. And for iOS has its own proprietary graphics framework called Metal, whether it is for your phones, tablets, or your Mac OS devices. iOS has its own proprietary graphics rendering pipeline and API called Metal, and that is what it uses. But Unity very, very easily integrates with all these APIs, and it helps you create cross-platform, interactive, and scalable applications for all these platforms. What all have people built using Unity? Like I said, both games and non-games. Two of the most popular, VR, AR games that have come out in the last 5-6 years have probably been on AR. It is probably Pokemon Go. I spoke about it a little earlier, if you remember. And on VR, essentially this game called Beat Saber, which is hugely popular, made several millions of dollars in revenues within the first 1 or 2 years of being released. And a little while ago was bought by Facebook. I think about 2 years ago, Facebook went and bought Beat Saber. It is a very simple game studio. I think, if I'm not mistaken, it was a 5-member company, the company that produced Beat Saber. And, their revenues were so good and they became so viral that within a short period of time, I think basically Facebook purchased them for several $1 million, right? That is all it required. And similarly, the movie Lion King, several animations and VFX required for that particular movie were done using Unity, were rendered on the Unity engine. And Google DeepMind, which some of you might have heard about, is one of their largest AI ML platforms that Google has created, that Google has set up, right? And it is in fact a separate unit inside Google that is kind of researching several aspects related to AI, ML, NLP, all these technologies that involve big data. And Unity is also being used there for certain simulations and creating certain visual simulations, and for visualizing certain particular forms of data. Unity is being used by Google DeepMind as well. Now, Unreal Engine. So I spoke about two engines being there that kind of help facilitate VR AR development. One was Unity, the other is Unreal Engine. Just like Unity, this is also a video game engine, right? It was originally built for creating a particular, it was originally built by this company called Epic Games, right? In fact, it is still maintained and released by this company called Epic Games. And they created this particular game called Unreal Tournament, right? And this was in, if I'm not mistaken, the late 90s. They created this game called Unreal Tournament. And to build this particular game in-house, they were using this particular game engine to, essentially templatize and to create a better workflow for churning out more levels and for churning out more content for their game. In-house, they were using this engine called Unreal Engine. And they realized that their game engine was so user-friendly and actually so compatible with several platforms that, was actually so usable rather, that they could just release the game engine also into the market and allow game developers to use their game engine for creating whatever experiences, for creating whatever games, for creating whatever interactive experiences they wanted to create. So it started with early versions called Unreal Engine 1, 2, 3, and so on. Right now, the industry standard is Unreal Engine 4, but even that is slowly going to be overtaken by Unreal Engine 5, which is coming out in early 2022. They have already released preview versions of Unreal Engine 5, and very soon in 2022, the more stable version is going to come out into the market. Now, Unreal Engine slightly different from Unity. It is originally built on C++, not on C#, and it is entirely open sourced. So Unity is proprietary. It is owned by Unity Technologies, but Unreal Engine, although it is owned and operated by Epic Games, and also it is maintained by Epic Games rather, it is completely open sourced and it is available on a private repository on GitHub. So literally anyone who has a GitHub profile can just literally go and download the entire source code for Unreal Engine. You can create your own forks, you can manipulate it how you want, and so on. But of course, there are certain standards and there are certain things you should be careful about before you mess with any source code. But at the end of the day, it is completely open sourced and it's a freeware. It is a freeware up to a certain point. If you create a revenue generating application or you create an app that is going to give you certain revenue, then beyond a certain threshold, you have to pay a certain royalty to Unreal Engine. But until you obviously hit that point, it is an open source, freeware, free to use for any independent game developer or any independent 3D designer, right? The way it is different from Unity is that it employs something called visual scripting. It does have regular, typing based scripting as well for programming and coding, just like you would on C#. But it has this other technology called visual scripting, where essentially a lot of the lower level functions are abstracted into simple flowchart like nodes, right? If you need to, say create a for loop, right? On Unreal Engine, it is as simple as dragging and dropping a node which describes a for loop. Drag and drop it into a flowchart and just mention your constraints, mention your limits, and mention the function that it needs to perform, and that is done, right? It is a slightly higher level programming language as compared to like C++ or C#, which are low level programming languages where you get a lot more access to certain manipulations. Unreal Engine's visual scripting called Blueprints is a slightly higher level language where the lower level functionalities are abstracted in the form of certain functions, modules, and nodes. So it is a little easier for a person who is not very familiar with programming per se, but at the same time, it is also important that you understand the lower level functionalities before you actually go and start developing visual scripts. Now, what have people built using Unreal Engine? Again, like I said, cross industry. It has a lot of functionalities, whether it is in gaming or content creation or in films and animated movies. Several TV series, such as you might have heard about The Mandalorian, Westworld. These were all popular TV series that came out in the last 2-3 years. Several animations and several scenes that required some form of VFX or animation were created and rendered on Unreal Engine. Thor, one of the upcoming movies from Marvel Studios, is going to be made. A lot of parts of Thor are expected to be made on Unreal Engine. Some of the more popular mobile and PC games that have come out in the last 2 years, right? Whether it was Fortnite, I spoke about Fortnite a fair bit some time ago. An upcoming Batman game, Rocket League, a hugely popular game in the last 2 years. Raji, one of India's, if I'm not mistaken, one of India's first high fidelity games that came out in the last 1 year, built by an Indian gaming studio itself, was made on Unreal Engine. Tekken, again, a very popular game. So essentially, in a way, Unity and Unreal Engine have kind of cornered the gaming market, right? They have most gaming studios these days in the world use one of these for producing high fidelity, high graphics driven games. Unreal and Unity have become more or less the standards. Now, how do you get started with these game engines, right? This is of course the requirement for Unreal Engine. As you can see here, the source is from actually Unreal Engine's own documentation page. But broadly speaking, if you want to create for VR and AR, if you want to create for extended reality or VR AR applications, broadly speaking, the requirements are more or less the same in terms of hardware right? Especially to use these game engines smoothly without encountering too many problems, right? You need at least a Windows 10 operating system, 64-bit. With 32-bit, you definitely won't be able to operate either Unreal or Unity. You need an Intel or an AMD processor, at least quad core. You need at least 8 GB of RAM. You can still develop with slightly less hardware. Maybe 6 GB also should work, but 8 GB would make it a lot more easier and give you much better performance. Similarly, if you want slightly high-end performance, there are people who use Unreal Engine and Unity with as much as 64 gigs of RAM, right? Use SSD hard drives as opposed to your standard HDD. If you use SSD hard drives, obviously it will be faster. The lowest level GPU that is in the market for developing with Unity or Unreal is the NVIDIA GeForce GTX 970. Now the 970 is at least a 4.5-year-old GPU, right? It still works, but these days with GPUs, you have a much more newer, much more modern, much faster processing units called RTX. Whether it is the RTX 20 series or the 30 series, you have like much better GPUs in the market. The better your GPU, the better your RAM, the better your CPU, right? The much faster and much more easier it will be for you to develop in these game engines, and especially develop for VR or AR. Now, all these introduction that I gave was broadly for VR and AR both. I'll just for the next 10 minutes or so, I'll just describe how to develop, what are the standards for developing in AR a little bit. Why I'm specifically touching on AR is because like I said, AR is the more scalable of the two, especially for someone just starting off. someone who is just starting off developing for these technologies, AR is a little more attainable because the hardware requirements are a little less. You don't need to purchase a separate headset. You don't need to purchase a separate device. Your simple phone, whether it is Android or iOS, in most cases will be able to support AR, and it will be a little easier for you to start testing, start creating basic applications on AR. Right? There are a lot of tools available, which when I say tools, always assume that it goes in conjunction with Unity or Unreal, with Unity being the larger, generally the standard for augmented reality, right? For very easy AR development, Unity is generally the standard. You can use Unreal as well. A lot of people have created some very good AR applications using Unreal Engine, but in general, from our experience, I would say that Unity is easier for you to pick up and develop if you are trying to create some AR applications. There are a lot of SDKs and plugins that interface well with Unity when it comes to creating decent AR experiences. These are essentially plugins that you can just download off the Unity store. You just need to go online and search for these Unity plugins for these particular names, whether it is Vuforia, ARKit, ARCore, etc. They interface perfectly well with Unity, and you can start developing for them. So how do you choose which SDK you want to use and which particular which particular plugin you need to start using? At the end of the day, very simple. It depends on because there are so many available. It can obviously get a little confusing, right? Like I showed here, there are so many: Simple CV, AR Toolkit, Wikitude, Kudan, Vuforia, ARKit, ARCore, and this is not even exhaustive, right? There are at least 20 more AR plugins that you will find online, which can perform some basic tasks for you to produce or create certain AR applications. So how does one choose what you do? It kind of depends on which industry or sector the app is being built for. Depending on that, you will find certain specific AR plugins, right, which come with certain inbuilt libraries and inbuilt functionalities that make it a little easier for you. And also, it also depends on which programming language that you want to use, right? If you're using Unity, that is C++, or basically C#, then nothing like it. You will find a lot of available documentation. You will find a lot of help. You will find a lot of online communities which are ready to help you with certain problems that you might face. Any bug you face, you just post it online on the Unity chat rooms or the Unity communities forums. Somebody will respond, or somebody in the past will have encountered that same problem, and there will be a solution for it. So because the ecosystem is fairly mature for Unity when it comes to AR development, it is generally advised that you go with Unity for creating AR applications. And the license type, of course, a lot of these SDKs are free. Some are paid for, like Vuforia is a paid SDK. But the advantage, of course, is if you're using it for academic purposes, in most cases, either it is free, especially if you're using it in a university environment, either it is free or there is, a very, very minimal license fee attached to it. So it is definitely much more, feasible for you if you are creating it for either university or academic related purposes. Now, there are four main SDKs that are the industry standard when it comes to AR development. That is ARKit, ARCore, AR Foundation, and Vuforia AR. Right? These are the four plugins that you can very easily install onto Unity. Right? If you want to start creating AR applications. When I say the four main horsemen, these are the industry standards right now. Any decent, scalable, flexible, user-friendly AR application that is found in the market right now, you can be rest assured that it is using one of these frameworks, either a combination of ARKit and ARCore, depending on iOS or Android. AR Foundation is Unity's own inbuilt AR framework, and Vuforia AR, which is a separate, SDK released by a different company, but which is fast becoming a standard on its own because it is quite user-friendly, and it is also one of the early companies that started delving into AR. And because they've been doing it for the last 8 or 10 years, Vuforia has in a way become slightly better at several functionalities that you need for AR, right? And it is, and all of these are the advantages, except for ARKit, which is of course in a way landlocked, and like everything else that has anything to do with Apple, it is restricted purely to iOS and Apple devices in general. All of these other frameworks are cross-platform. They can be used either on Android, iOS, Windows platform, or so on, right? They're all cross-platform. Now, I'll tell you just a little bit about Vuforia and why this is probably the stepping stone for you to even just experiment a little bit with AR, right? Vuforia essentially comes with its own proprietary engine as well. If you don't want to even install Unity and Unreal and literally take one 3D model, say you have a 3D model of some induction motor, right? And you want to put that 3D and you want to make one simple application which allows you to open that particular app, press a button, the 3D model of that induction motor turns up in front of you and starts, and based on the touch of a single, and you just touch that motor, so it starts working or it starts animating, something like that. If you want to just do something as simple as that, right? Vuforia Studio or Vuforia Engine can help you very easily. This is a very simple low code, no code kind of platform. You don't have to write too much code. In fact, you hardly have to write any code at all. You just install Vuforia Studio. You can literally drag and drop a 3D model in and package an application, and you'll have an app that can create and you'll have an AR application ready in front of you, right? That's how easy it is. So I'll just give you one example of something that is built using Vuforia engine, right? This is, as you can see, a 3D model of a car, right? And this car is basically spawned on top of a white table. This table is, of course, in the real world. It is a flat surface, and there is a car spawning there, and it is built using Vuforia engine. So I'll just play this video, and you'll realize what I'm saying. Yeah. So see, basically all the person had to do was scan the table, and a virtual model of the car spawns in front of them, right? And various interactions like changing the color of the car, getting the car to rotate, seeing what the features are on the car, so on and so forth, can be easily integrated. This is, of course, analogous to any other interactive framework that you want to create. If you want to, like I said, just spawn the model of an induction motor, right? You can do that. If you want to teach people very simply how an induction motor works, right? You can spawn a model there. You can show them which different parts of induction motor are there. You can show them how it functions. You can show them how, how it does what it does. All of that can be done using just very, very simple interactions and very simple minimal level of coding on Vuforia engine. I was talking earlier about medical use cases, right? So here again, see, I know this is again very primitive. It's not going to replace actual medical, training right now, at least. Maybe in the future, but it is getting there. Maybe in the next 5, 10, 15 years, as the technology keeps improving, becomes more accurate and becomes more scalable, it will actually replace like existing, modes of communication and existing modes of academic training, right? But this is basically a 3D model of a heart. You can see the different parts of the heart are labeled, right? Whether it is the ventricles, the aorta, the arteries, etc. All of those are labeled, and this is without actually having a real, specimen or a real 3D model, in front of you. You're just using a digital twin, a virtual version of that, to show people different parts of the heart and to actually train them on the very basics of the human heart. here you see someone, if they want to, decide how a particular, I don't know, how a particular furnishing inside their house would look, right? Even before actually purchasing that particular device, particular piece of furniture, right? Using AR, they'll get the perfect 3D model of that particular furniture or that particular piece of furnishing that they want to buy. They can just overlay it on their existing real world, hold the phone. It will create that, they'll have 3D model ready in front of them, place it wherever you want in your house. You can kind of visualize how it will look, right? How much space will it occupy? How does the color go with the existing colors in your house, and so on and so forth. All of those basic ground level decisions can be made without actually having the physical inventory or the physical asset in front of you. This I think I just described a little earlier. And yeah, here this is just another example as well, what the kind of things that can be done, right? A person, you can just literally hold your phone up on top of your real world. These days, your phone cameras, thanks to computer vision, basically, as many of you might know, thanks to CV, it can actually recognize various shapes. Your phone camera can actually recognize various objects. Thanks to the power of machine learning, it is capable of looking at a particular shape, looking at that particular feed, and recognizing what that particular object is, right? So when you hold your phone up, say on your car dashboard, on front of your steering wheel, on front of your entertainment system, and so on, it is actually capable of recognizing different buttons on that steering wheel. It is capable of recognizing the gear shift. It is capable of recognizing the entertainment system, and so on. And using the power of AR, it can overlay information on it, right? If you bought a new car, you don't know what certain buttons on that car do, right? Especially the entertainment system can be so complex. Sometimes you don't really know how to, play certain functionalities. Just hold your phone up. Your phone will recognize exactly what those buttons are, and it will overlay information on your phone, on the camera feed on your phone, right? About what each of those buttons do. So at a very simple level, it is a training experience, right? It's training you on how to best utilize the features in your car. And all of this is done without necessarily having someone physically teach you what each of this does. A simple phone application is enough to actually train a person on how to start using these devices. So I think I showed this graph a little earlier. I brought it back because I kind of wanted to explain the context again. So 2021, where are we right now when it comes to AR and VR? We are definitely on the upward slope. That is the slope of enlightenment. We have crossed the path where people were disillusioned with AR, VR. These technologies are here to stay. They are not going anywhere. They are becoming more and more entrenched, if anything. VR has already reached a point where it is actually being meaningfully used for productive use cases, especially in the industry. A lot of training, a lot of employee upskilling, a lot of employee onboarding activities are all being done in the industry using VR, right? Especially in a situation where you can't necessarily take 150 people and take them to a particular training location, right? You want to train them on how best to use certain devices, on how best to deploy certain tasks, right? You want to train them in VR, right? So VR has already reached that level of productivity where a lot of industries across sectors are using VR for meaningfully and measurably training their employees on certain complex tasks. AR is still in the stage where it is, of course, extremely scalable and has actually reached the consumers a lot faster than VR. But to be used for actual productive use cases, AR is still getting there. But I think very shortly in the next few years, you will find that both AR and VR have hit this plateau of productivity and will become even more entrenched as technologies. Yeah. So thank you. That is basically my talk for today. I didn't hear any questions or any doubts during the talk. So if anyone has any doubts or anything, you can please feel free to either post it on the chat or ask me directly. I'd be happy to answer it. And even later on, if you have any doubts, anything at all, I think Dr. Vijay Kumar has my contact details, and you can definitely reach out to me.
Hi, sir. I have a few doubts.
Okay, yeah.
As you're basically into AR, VR, could you please recommend on how we students can start our career in XR field, sir?
Sorry, can you repeat that bit? I did not hear you. There's some
Like,
disturbance.
am I audible, sir?
Yeah, yes.
Yeah. Could you please recommend on how we students can start our career in this XR field, sir?
Yeah, so again, like I said, it's when you say career, right? It is basically the 101, right? That's the building blocks or the foundation to learning anything to do with AR VR is not unlike how would you build a career in computer programming, right? All of this that you are seeing, all of which I explained in the previous slides, is essentially learning how to program for AR and VR, right? So you don't actually need to, uh, start at level 5, which is learning how to program for AR VR. You start at the basics, right? First, learn basic programming concepts, that is C, C++, C sharp. Like these are your entry level programming languages. Once the user is a little comfortable with those, like I said, someone who is comfortable with C++ and C sharp can very quickly start learning Unity and Unreal Engine, which are the level 2 of learning how to program for VR and AR, right? And once you have entered Unity and Unreal Engine, then there is no looking back, because if you are comfortable in using Unreal Engine and Unity, then AR and VR plugins are extremely easily available, right? And I would like to frankly say that VR is still a little difficult for the consumer to an independent consumer to commit to, because yes, you need to purchase an external hardware device like a headset to actually try out VR. But AR, like I said, is available on your phone. So you can just sideload an AR application onto your phone and you can start using it, right? So AR development is a lot more easier for people to start picking up. The level 1 is to learn some C, C++, and C sharp. Level 2 is to learn some Unity and Unreal Engine, right? And after that, it is fairly straightforward. And about learning resources, you don't really need any additional classes, or you don't need any additional academic framework for this. Actually, everything is available online these days. Both Unity and Unreal Engine have done a great job in the fact that they have made almost all their video tutorials accessible. Depending on, of course, certain subscriptions that you have, you'll get access to advanced tutorials on Unity. But beyond that, and you might have to pay for certain additional tutorials, but all your entry-level tutorials on how to use Unreal Engine, how to set it up and start using basic functionalities, similarly, how to set up Unity, how to start using basic functionalities for Unity, all of that is available online. You can just search for Unreal Engine documentation, video game tutorials. Similarly, for Unity, you can just search for Unity Academy or Unity tutorials, and all of these well vetted and well maintained video tutorials are available online. So there is very little barrier of entry for someone who actually wants to experiment with AR and VR right now, right? In terms of creating new applications and in terms of developing new applications.
Sir?
Yeah.
As you have already mentioned earlier, as the virtual world will surpass the real world, would there be any constraints developed by companies for the users in order to limit the usage of AR, VR in future and to be in real world, which I mean like something like laws for robots? So,
sorry, I didn't get the last part of your question.
like there are laws for robots, right, sir? Like 3 laws for robots.
Yeah, that is there.
So during development, so will there be some kind of constraints developed by the companies for the users in the future in field of AR, VR, sir?
Yeah, so the laws for robots that you're describing, I think, is not really a legal law per se. It is basically Asimov's 3 laws of robotics, is I think what you're talking about, right? So those are not legal laws as such. Those are just laws created by, or rather theorized by, Isaac Asimov as to what constitutes a robot, right? But if you're asking about whether there will be real world regulation and laws created around AR, VR, very frankly, I don't think anywhere in the near future in terms of creating restrictions for people. it laws for AR and VR will, or anything to do with the digital revolution will probably be around rules related to privacy and data privacy and so on, all of which are still at a very nascent stage around the world. Because look at it this way. One of the ways in which an AR headset is, or an AR headset is able to tell you where is able to spawn a 3D model in front of you, right? Is basically using the cameras on front of the AR headset, right? Now, if you're sitting at home wearing this AR headset, at any point in time, this camera is always on, right? Because it needs to track the environment around you. This camera is able to track whether there is a flat ground plane in front of you on which it can spawn a 3D model, whether there is a table in front of you, or whether there is a wall in front of you on which it can overlay certain information, all of that. All of these things within your house or within your private setting are actually being recorded on a camera, right? This is not to scare people saying that, don't buy AR or VR headsets. I'm just saying that, there is a lot of this data that is being accumulated in by these companies for, of course, training their AI and ML algorithms to function better. But at the end of the day, all this data is being recorded, right? The camera on your phone is sometimes switched on even when you actually don't even know that it is on, right? Because certain sensors on your phone work only if they have access to the camera. So even when you don't know that your phone camera is on, sometimes it is on, actually, it is passively on, tracking the environment around you, right? So if at all laws are created to restrict the use of AR, VR, it will probably be in these in this situation where around data privacy, they may bring out laws saying that certain cameras need to be switched off when devices are in passive mode and so on and so forth. But right now, in terms of restrictions for developing AR, VR, I don't think anyone is actually going to restrict anything. Governments are, for good or bad, governments are very far behind in recognizing the potential pros and cons of these kind of technologies.
Thank you very much, sir.
Thank you, sir.
One question in the chat box. Is there any funding for getting these expensive headsets? One participant asked.
So funding depends on your requirement, basically. I guess, see, the cost of these headsets, when I say expensive, it's all relative, right? If you are if you're an individual user, the cost of, say, an Oculus Quest, which is the best headset in the market right now, right? The cost of the Oculus Quest 2 headset is around 30,000 rupees INR, right? 30,000 rupees. And if you want to develop VR applications that can work on the Oculus Quest, you will have to invest in a desktop or a laptop, which is around 1.2 to 1.8 lakhs. So the total cost is around 2 lakhs, 2 to 2.2 lakhs, right? Including the headset and the laptop or the desktop on which you can create these kind of experiences. Now, if you're an individual user, yes, of course, this is very expensive, right? Yes, okay. So for research, now for research purposes, like I said, the cost is around 2 to 2.2 lakhs. Funding at universities and academia, I'm personally not too sure. That will probably depend on a case-to-case basis, depending on the particular university or college you are affiliated to, right? But the general cost, say tomorrow you want a hardware setup where you can start developing VR, AR, right? The hardware cost will be in the range of 2 to 2.2 lakhs per unit, right? For the headset plus a desktop or a laptop station on which you can start writing your code or start programming.
Thank you very much, sir.
Yeah.
So thank you. I hope there was a very good response to this. It's a very fast-growing field, and I hope many people will take up this. Since being an academic field, many academicians are here, so they will take up as a research field and also a career changing scope also. So it has a tremendous scope for potential for further enhancement, and it is going beyond the AI. I think AI, AR. We were talking about AI a few months back. Now it has become AR. So it will be like a exponential rise in this field. So I hope all of them will take up this particular field, as a lot of students will want to take up as a career. So I really thank from the Department of Mechanical Engineering, Mr. Angad Raghavan, for taking time out from your extremely busy schedule and giving a very, very comprehensive and very easy to understand presentation on AR and VR, sir. Thank you very much, sir.
Thank you. It was my pleasure. And as I said, I think Dr. Vijay Kumar, you have my contact details anyway. So if anyone has any doubts or want to reach out or at any time want to discuss anything, right, related to AR, VR, you can just drop me a note and, we can definitely get in touch. I would be happy to clarify any doubts, any clarifications. Yeah.
Thank you very much, sir. Thank you very much, sir. Thank you very much.